Solving equations in factored form. Okay. Let me ask you a couple of questions and see what you can tell me. If you were to see an equation like that, would you be able to solve it? How would you solve it? What would you do? Art. Get n by itself, subtract 6 from both sides, and n would equal -6. How would you know it's correct? -6 plus 6 would equal 0. What if we had 3n is equal to 0? What would we do? Marlia, what's happening to n? By 3. The opposite is to divide both sides by 3. N would equal 0. How do you test it? Plug in a 0 for n. 3 times 0 just equals 0. Good. 2 for 2. And well, something like this. Two-step equation. Mark. Subtract 12 from both sides. Which would leave you with 3n is equal to -12. Divide both sides by 3. N would equal -4. 3 times -4 is -12. -12 plus 12 would equal 0. Any questions on those? Questions on those regular equations? Okay. Now we're going to do for today, we'll be using similar equations like this, but we're going to have to come up with them first in some cases. Which is going to be all right. Solve an equation that looks like this. Now, we have to take a quick look at this to find out actually what's happening. What is the main operation that's going on in this problem? Maria, you would be correct. Why would you say multiplication? What property would you call that? Yeah, I mean, we're essentially going to have to run the distributive property, but at the same time, no matter what the n is, the first thing you'll do with n is subtract it because it's in parentheses, potentially if you don't use the distributive property. Well, you'll have to anyway. And then we will multiply the n on the outside with whatever we have on the inside. Now, what do you know about multiplication and a multiplication problem equaling 0 that we have up here? Mark. How many factors have to be 0 for our product to equal 0? 1. Only 1 has to be 0 for it to equal 0. I've got two different scenarios here. In multiplication, either this n could equal 0, and I can multiply it by whatever this is, and I'll still get 0, or this n, what's on the inside has to equal 0. So I'm going to solve for both. Let's solve for this n first. Make that one 0. How am I going to make it 0? Is there anything with it? Can I just say it equals 0? I can for that one. Let's plug it in. Let's say I should have two different solutions. If I plug in 0, I would have this. opposite work? If I plug in 0 into my original equation, do I get 0? Well, I can't multiply yet. What is 0 minus 5? Negative 5. 0 times negative 5, does it equal 0? Good. Now, let's solve for this end. Let's ignore this one for now because I've already solved for that end. And let's take that n minus 5, and let's just have it equal 0. It should be very similar to what we did at the beginning of the lesson. How would I solve something like this? I would add 5 to both sides, and would then equal 5. So let's plug it in. It's no longer 0. Now I'm going to plug in a 5. So I put a 5 on the outside, 5 for n on the inside, and it's got to equal 0. 5 on the outside times, what's 5 minus 5? Does 5 times 0 equal 0? Okay, so I've got two different solutions. I would solve this by saying n is equal to 0 and n is equal to 5. Both solutions. They'll both give me 0. N and 3n plus 12 equal 0. So we're going to solve for two different n's here. So let's solve for this one first. I need this 2n to equal 0. How are we going to do that? Divide both by 2. N equals 0. Good. Next one. 3n plus 12 equals 0. First thing we need to do, mark. So n equals 0. Any questions? Try one. Marlia? Yeah. We're gonna, if there's two separate ones, like here, there's got one on the outside, one on the inside. Take this one on the outside, have it equal 0, solve it. Take this on the inside, have it equal 0, solve it. Just like you're doing two different problems that equal 0 to find out what n equals in each case. So when we see this one, 3a and a plus 2 equals 0. Solve for the 3a. 3a equals 0, therefore first a is going to equal 0. Solve for the a plus 2 equals 0. Subtract 2 from both sides. A equals negative 2. A equals 0 and a equals negative 2. Okay? Question? If it's structured like that. Those are kind of layups. Those are gimmies. But as you know, the first examples I put up are going to be a little bit easier than the other ones. Okay? Sometimes you'll see them like this. So we can assume that b plus 1, b plus 3 is maybe something that could be FOILed. Okay. Or something that was FOILed, or however you want to look at it. Again, I've got two separate b's. So I'm going to make this b plus 1 equals 0, because again, two sets of parentheses really mean one operation. They're jammed up right next to each other. Right, so only one of them needs to be 0, but I'm going to find out what's going to make each of them equal 0. So I'm going to take this b plus 1, make it equal 0. I'm going to take the b plus 3 and make it equal 0. So let's subtract 1 from both sides. B could equal -1, or subtract 3. B could equal -3. Either way. Yeah. No. Not all. Could be a little bit more, but essentially. As you look at written numbers 19 through 47, are there any there that you think, just by looking at it, you wouldn't be able to solve? Basically, if you can solve an equation, you're going to be fine. But I'd be happy to do any of the ones from 19 through 47, just to prove it to you. Okay. 33. Okay, let's try it. I'll put it up, and we can try it. 2y plus 8, 3y plus 24 equals 0. So y equals -4. Y equals negative. Got it? Got it? Yes? Okay. Tomorrow, we'll have to go back a step. So tomorrow you'll get something like this. X squared minus 9 equals 0. And then we look at this and we say, oh, that's difference of squares. So block out that top part. This looks like a problem that you'd have for today, right? So then tomorrow says you have to go here today. So your solutions would be 3 and -3. Plug it in. Plug in 3 for x. What's 3 to the second power? 9 minus 9, 0. -3. -3 times -3, 9 minus 9, 0. See, at first glance, you might be like, oh, that's easy. That's 0. Plug in 0. What's 0 times 0? 0 minus 9, -9, not 0. Okay? So, only in certain formats, Mark, can we just assume the 0. Okay? So we'll do page 194. '20 through 46 even.